Cool, evening everybody, good to be here. So first things first, quick show of hands, does anyone actually drive a Jaguar or a Land Rover? One person.
I don't drive one, unfortunately, but still, I'd really like you to come.
Okay, well that's fine. You've got good taste, so thank you for that. Cool.
I have the first electric one.
You do? Nice one, thank you, good. Good, we'll talk about that in a second. So we're going to talk about vehicle software on cars, about how we update that software with our DevOps delivery platform, and a couple of specific DevOps practices that we use as part of that process. So hopefully give you some interesting insights into applying DevOps in a slightly different context to what you might have seen before. Cool, let's get into it. So usual intro stuff. So yeah, I'm head of engineering at JLR for the last 5 years or so. My background is software engineer, principal, engineer, manager, architect, all the titles. Based, obviously you can probably tell from my voice, not from London, based up in Manchester. So I've travelled from the cold, dark north to the bright lights of London. Not had a nosebleed yet, but I'll keep you posted. And I love DevOps, right? I love the technical side of DevOps. I love the people and the cultural side of DevOps as well. I will happily talk about DevOps all day long, so you've been warned. And I'm also a bit of a car geek. So different cars, different forms of motorsport. So the fact I get to do software and DevOps stuff for a car company means I've hit the career jackpot, I guess. I have to remind myself of that in some meetings, but yeah. All my links and stuff available at the QR code I'll put up again at the end, but I've got quite an unusual surname, so I'm quite easy to find in all the usual places. Do reach out if you want to talk about any of this stuff, always happy to do that. Cool, anyway, we're not here to talk about me, let's talk about software on cars then. So cars these days are not just bits of metal screwed together anymore, right? They are basically great big mobile devices these days, big IoT devices on wheels. And the fact is, some of our modern cars have in the region of about 100 million lines of code on them, which is quite a terrifying amount, but that's because software does everything on cars these days, it's everywhere, right? So people tend to think of the infotainment screen on the dashboard, so with your media and sat-nav, etc. But software is doing all sorts these days on the car. So you've got the actual dashboard itself. You don't have those manual dials anymore. It's all digital. It's all software driven. And you've got engine management systems, brakes, cruise control, electric seats. They've all got some software component to them these days. So there's code all over the place in these cars. And to give you an idea of what the architecture looks like, that software is deployed on what's called ECUs, or electronic control units. Which are like little computers dotted around the vehicle essentially. So to use a DevOps analogy, you can think of the architecture, the ECUs are a bit like pods in Kubernetes, I guess, and the car itself is like a great big Kubernetes cluster. That's one way of thinking about it. So we can update those ECUs independently. Fairly sure it's illegal to do a DevOps talk and not say Kubernetes, so there you go. If anyone's playing buzzword bingo, cross that one off. So we've got all this software, which means we want to be able to update it, of course. So the way that used to work, and still does in some situations, is you would have to take your car into a dealership, into the workshop, and a technician would physically plug a laptop into the car, download, install the updates. Takes a couple of hours to do that, so it's not terribly convenient for the customer, right? You've got to take time out of your day to go to the dealership. You can't use your car while it's being updated. And if you've just spent 150 grand on a Range Rover, you want to be able to drive it, not have it in a workshop. So it's not terribly convenient, but it's not great for JLR either, because long story short, we have to pay those dealerships for doing those updates. So every time we do that, it costs JLR about 450 quid, which on its own isn't too much, but when you consider 1 million or so vehicles around the world getting multiple updates, it starts to get quite expensive quite quickly. So nobody's a winner in that. So there must be a better way of updating this software, and there is, and it's called SOTA, Software Over the Air. So that's the platform we're going to talk about in a second. So the analogy I use here is the iPhone, right? So if you've got an iPhone, you don't take that into the Apple Store to get your apps updated. That would be a pretty rubbish user experience, right? What you do with your iPhone is you can download updates over the network in the background while you're using the phone. You can schedule when those updates get installed. It's free of charge. You can sort of minimize the disruption to your usage of that phone. And it's exactly the same experience for a car on this SOTA platform. So the car has a 4G SIM card in it. The update gets downloaded in the background as you're driving around or parked up or whatever. You can schedule when the update gets installed. So again, we can kind of minimize disruption to the driver. and it's free of charge as well. We don't charge for these updates. So it's an iPhone-like experience for drivers of our vehicles is what we're sort of going for with this platform, essentially. We've got, well, by the end of the next month, we'll have about 1 million or so vehicles globally connected to this platform. So it's updating our cars all around the world, all the different models. So it's at quite some scale already. And what that means is we can deploy fixes, patches much more quickly, cost effectively, at a much bigger scale than if we had to get everyone's car into a dealership. And we can also deploy enhancements and actually upgrade the software, right? So that's the really cool part of it. I think the best example of that is JLR has a racing team in something called Formula E, if anyone's ever watched that. Electric form of motorsport, that's the car there in the middle picture. So the racing team was able to make some software tweaks that effectively improve the efficiency of the battery in the racing car, right? So we got more miles out of the battery effectively. Then the engineers within JLR were able to make a similar software tweak to one of our road cars, the Jaguar I-Pace that you used to have. And we could then deploy that same software update via the SOTA platform to all of the I-Paces around the world. So what that means is someone who bought an I-Pace like 2 years earlier could download this update overnight and essentially improve the range of their electric car via this update, which I think is pretty cool. Because previously, when you used to buy a car, it would gradually get worse over time the longer you had it, right? New models get launched, better features. What we can do with this sort of DevOps SOTA approach is we can actually improve vehicles over their lifetime, which completely changes that customer experience, that ownership experience. So it's quite powerful. So that's some of the context, that's software. Let's have a look at the actual platform itself behind this. Excellent diagram. So you can think of all these separate components as essentially being like a CI/CD pipeline for vehicle software. That's what we're going for here, right? Each of these systems themselves are also built using DevOps. So there are a set of microservices databases behind these systems. So we've sort of got DevOps on top of DevOps, but everyone needs more DevOps in their life, right? So that's good. The heart of it is this campaign manager. So when we run a set of updates, it's called a campaign, an update campaign. So the campaign manager system essentially pulls together all the software we're going to send out and the list of all the vehicles we're going to send that software to. And then coordinates that update to the car via a system called Harmon, which actually sort of does the installation on the vehicle itself and gives us some feedback via the logs and the message queues. I'll dig into those a bit further when we talk about monitoring in a second. We've got vehicle software repository. So this is where we store the various software packages that we might want to send out to a car. So in DevOps terms, that's a bit like a container registry, right? If anyone's using Amazon ECR or Docker Hub, it's the same sort of concept. It's built on top of something called Artifactory with some microservices for processing and packaging that software up. We've got digital twins. So this is a couple of big databases that store configuration information about the vehicles. So for every car that's connected to the platform, we store information about which version of software is installed on each ECU. And there's some quite complex logic and dependencies between ECUs, different software versions that digital twin sort of models out essentially. And then the vehicle targeting service is used by Campaign Manager to essentially get the list of vehicles from digital twin that we want to include in an update. So an example campaign might be, I want to update the infotainment system on all Range Rovers that are currently running version 3.5 in Canada, for example. And the vehicle targeting service will then interrogate digital twin and come back with a list of vehicles that are compatible with that update and include them in the update. So that's what the sort of high-level process looks like on the platform there. Most of these are Java, Spring Boot microservices. There's a bit of Golang in the vehicle software repository and a bit of MongoDB behind some of these databases as well. All in Kubernetes, obviously. Cool, so let's talk about some specific DevOps practices that we use as part of this process and at the back of that, and again, give you some insight into that. So the first part is testing, important part of any CI/CD processes, different types of testing, of course, especially when you're dealing with vehicle software. We'd prefer not to kill anybody, so it's important that we do some different types of testing. And it starts with something called a rig, which is this picture on the right here. So a rig is essentially a mock-up of part of a vehicle, if you like. So it's got a subset of the ECUs on there. This one, hopefully you can make out a couple of screens at the top there. So it's got the infotainment screen, the dashboard on there, and behind there you can't quite see is some of those ECUs widened as well. Not all of them, just a subset. So this is a bit like a staging environment, right? So you can do some initial form of testing, and some of those dependencies are mocked and stubbed out, so we can't do full end-to-end testing, but we can do some initial testing with a rig. Then we move into the engineering fleet. So these are real vehicles used by engineers within JLR, but they're not fully representative of production customer vehicles. They're sort of a bit of a mishmash of different vehicles. So you might get a Range Rover running some parts or some software from a Defender or a Discovery, different models, for example. But they allow us to do some more end-to-end vehicle testing, just not fully representative of the production environment, essentially. And then we move on to the management fleet. So managers in JLR get company cars, and we can use those cars to, again, do some end-to-end testing. So these are real customer-like vehicles, right? So we get representative end-to-end testing at that point. And in a sort of self-contained fleet, in this management fleet as well. So this is a bit like doing a canary release. If anyone's doing canarying in the cloud environment, same sort of concept. Roll the update out to a small percentage of production, do some testing, make sure it's all right, and then we can either roll it back or roll it out more widely to all of our customer vehicles as well. So obviously we don't want to break a manager's car, but it's better doing that than breaking a customer's car. Right? And none of the directors have shouted at me yet, so it must be working fine. So that's testing. Moving around that DevOps loop, the next part is the deployment itself. So again, quick show of hands, anyone doing blue-green deployments in the cloud? Yeah, a few people, cool. So for those of you that don't know, blue-green is essentially running two versions of your production system side by side. So that means you have one active version at any one point receiving production traffic and one inactive version. So you can deploy your new version to the inactive part of the blue-green, run some smoke tests, etc., and then flip over, make that version active. And if anything goes wrong, you can very quickly roll back to the previous version because it's just deployed side by side. And we can do the same thing in a car. So a lot of our ECUs, not all of them, but a lot of them are what's called dual bank, which means they have those two side-by-side places where we can deploy software into the ECU. So we can essentially do blue-green on the car as well, right? So one of them's active, one of them's inactive. The update gets downloaded to the inactive bank in the background as you're driving around or parked up or whatever. We can run some smoke tests, some verification tests, switch to the new version, and if anything goes wrong, we can very quickly then roll back to the previous version because it's still installed and deployed on the car, so we get much faster rollback at that point. So yeah, blue-green on a car, that's pretty cool as well. And then continuing around that DevOps infinity loop, the last part is continuous feedback or monitoring observability. So how do we do that? How do you verify a production deployment if your production environment is a car on the other side of the planet? You can't go and look at production and check it. We can't really phone all of our customers and say, did we break your car? Doesn't really scale very well. So how do we do it? So if you think back to that platform diagram, well, we had the message queue, the logs, this is where that comes in. So when a car's first built, when it rolls off the production line in the factory, it checks in with our platform for the first time and says, hey, I'm a new car, I've got these versions of software installed on these ECUs. We create a record in that digital twin system, so we know at that point that the car was built, all the software that was running on that car. Then every time we run an update, we also get some feedback via the logs, via the message queues about that particular update, so whether it was successful, whether it failed, any error messages, and also at the end of the update, what version is then running on the ECUs again. And that's why we're doing it. Then the other part is on every ignition cycle, so whenever the vehicle is started up, essentially, it also checks back in with our platform and says, hey, me again, just to let you know, I've got these versions of software on my ECUs now. We can update digital twin. And that third one's quite important because if you think back to the start where I talked about cars going into dealerships to be updated, that does still happen in a lot of scenarios. So if we only updated our platform when we were doing updates, we'd miss those ones in the dealership. So it's important that we get that check-in every time the car's started so that digital twin stays up to date and we can make sure we don't send any incompatible updates to vehicles going forwards. And you can see we can also build some Grafana dashboards on top of that digital twin data. Can't quite make that out, but this one's showing updates at various different statuses, downloaded, installed, failed, succeeded, etc. And shows some sort of business metrics there as well, which gives us that sort of observability angle from the DevOps perspective on this process. Cool, so we've seen software on cars, we've seen the platform, a couple of specific practices, just to wrap it up with sort of where we're at going forwards, etc. So we've done about 5 million individual updates via this platform globally. We've saved about £500 million for JLR. Going back to that point before about it costs money every time we go to a dealership, we've equated that to a sort of cost saving here as well. There's a lot of ongoing complexity and operational challenges with the platform like this, as you can imagine, not least regulations in different global markets. So California, I think, has some quite strict rules about over-the-air updates, for example. China, so China's JLR's biggest market, but anyone who's ever done any cloud work in China will tell you how complicated that is with the Great Firewall, rules around data sovereignty, etc. So the platform does work in China, but it's a whole different level of complexity. It's a whole different talk in itself. And then we've got like European regulations. So there's something called UNEC 156, which is about you have to show traceability of software changes to a car. So we've had to update the platform to accommodate for that as well. So there's lots of ongoing complexity as we roll this platform out more widely to more vehicles. But it also opens up lots of opportunities as well. So we've talked about SOTA, software over the air. We can also do something called FOTA, which is features over the air. So that's enabling and disabling features on the car via this same DevOps mechanism. So the example use case there is, let's say you run a vehicle rental company, Avis or something, and you've got a bunch of Range Rovers. You could potentially upsell features to people on the car. So you could sell, heated seats, for example. Daft use case because no one's going to pay for that. But you can sort of enable and disable features via this same DevOps platform. Change the customer experience, change the user experience going forwards. So lots of powerful opportunities going forwards by using DevOps on cars like this. Cool. So I hope that was interesting. So we've seen DevOps, we've seen software, seen the platform, how we try and use it, and hopefully it's given you some interesting insights into, like I say, DevOps being applied in a slightly different context. Like I said, reach out if you want to talk about any of this stuff any further. Always happy to do that. Other than that, thank you very much for your time. Cheers.